Hello and welcome to the Tentative Tutor channel. Here's an interesting one. Solve for x and y positive integers. X squared plus 648 is y to the fourth. We'll solve this by taking remainders on dividing by 5. So first we need some notation. This is read 17 is congruent to 2 mod 5. Meaning, when we divide 17 by 5, we get a remainder of 2. We say that 2 is a least residue modulo 5. So the possible remainders when we divide something by 5 are called least residues. And the possible least residues here are simply the integers from 0 to 4. First, we'll notice that these least residues are multiplicative and additive. For example, 17 times 14 is 238. When we take that modulo 5, the remainder of 17 when we divide by 5 is 2, 14 is 4, and we need only multiply the least residues modulo 5 of 17 and 14 to get the least residue of 238. That is 2 times 4, which is 8, but that's congruent to 3 mod 5. And also when we add them, 17 plus 14 gives us 31. Taking the least residues, we get 2 plus 4, which is 6, but that's congruent to 1 modulo 5. And we can see that 31 is in fact congruent to 1 modulo 5. So the idea will be to compare the possible remainders on the left side with those on the right side. When we square the numbers in this set, what can we get as a remainder? Well, let's give it a try. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9, but that's 4 mod 5. Finally, 4 squared is 16, but that's 1 mod 5. And we see that the only possibilities are 0, 1, and 4. Now the remainder when we divide 648 by 5 is 3. So we say 648 is congruent to 3 mod 5. In fact, it's 5 times 129 plus 3. So what happens when we add 648 to the left-hand side? Well, the remainders when we square an integer are 1 of 0, 1, and 4. And we said that 648 was 3, so when we add 3 to 0, 1, and 4, we get 3, 4, and 2. So we can only get 2, 3, and 4 as the least residue on the left side. What about y to the fourth on the right side? We already said that y squared was in the set 0, 1, and 4 mod 5. And y fourth is simply y squared squaring it again. So when we square each of these numbers, 0, 1, and 4, we're only going to get two possible numbers, 0 and 1 mod 5, because 4 squared is congruent to 1 mod 5. So we can only get 0 or 1 on the right side. Let's now compare the left side with the right side. On the left side, our only possible least residues are 2, 3, and 4. And on the right side, the only possibilities are 0 and 1. But these two sets have nothing in common. So the left-hand side can never be equal to the right-hand side. So this equation has no solution. It really is an impossible equation. Now here's our bonus problem. How many divisors does 1 million have? There's a trick to it. Can you solve this problem? Leave your answer in the comments. And once again, thanks for watching.